We factoring first when there was not a number in front of the x squared. When there is a number, the process for factoring is a little bit more complicated. And there's several steps that you have to follow. These steps would technically work for the problems you've been doing. It just takes a little bit longer. So the first thing that you want to do is make sure that your quadratic is set equal to 0. Make sure you have all of your terms on the same side. And then you're going to look for a GCF. A GCF is you're looking for what goes into all three of your terms. So let's go ahead and actually start with question number 1. 2x squared minus 6x minus 8 equals 0. Is there anything that I can divide all three of those numbers by? 2. So what I'm going to do is I'm going to bring that 2 to the front. And I'm going to divide out that 2 from each term, giving me x squared minus 3x minus 4. If I look here, 2x squared minus 6x minus 8, and x squared minus 3x minus 4. There's my first one. There's my second one. Notice how they completely overlap. Those are exactly the same quadratic. When I pulled out this GCF and I look at what's left in the parentheses, do I have a number in front of the x squared?
Yeah. Or no?
No, I do not anymore. So I told you it was going to get a little harder. Well, we're not really there yet. Because sometimes when you can find the GCF, sometimes it'll turn it into one of the easier problems. And you don't have to do all that extra work. So what I'm going to do is look at what's left here in the parentheses. I need two numbers that multiply to be negative 4 and add to be negative 3. What are those two numbers? Negative 4 and 1. Now your GCF, you technically don't need to lose that. And we have x minus 4 and x plus 1. And now I can set each factor equal to 0 to get my x-intercepts. If your GCF is just a number, you're not going to write 2 equals 0. That doesn't make sense. We've got this one, which would give us x equals positive 4, and this one, which gives us x equals negative 1.
What do you do with that 2?
If the question only asks for the x-intercepts, it doesn't matter. It's still technically part of the quadratic. If I just drop the 2 and I have x minus 4, x plus 1, it's not technically the same parabola as my others. It's not technically the same as this, but it does technically have the same x-intercepts. So, this quadratic right here is not the same as the quadratic without the 2. They have different vertex, they have different y-intercepts, but they do have the same x-intercepts.
So what, creates a parabola? Like, I get that equation does, but like, the square, yeah,
square.
But like, I don't want to sound stupid, but like in a real life type thing, is it like, do these come in like?
Yeah, any like projectile, any object that's thrown up, when you look at the that comes back down, throw a basketball, all of that forms the shape of a parabola. When you look at height versus time, a lot of that will have the shape of a parabola. All right, so try number 2. It's the same as number 1. There is a GCF, and once you take out the GCF, it becomes one of the easier problems. Did you all get x-intercepts at 5 and -3? Yeah. All right, so always look for the GCF because you might turn a seemingly difficult problem into an easier problem. If we look at number 3, is there anything that you can divide 9, 12, and 5 by? No.
I saw the 4 boxes. I thought I was going to get a 5.
No, you cannot. So there is no GCF. Now, the process of factoring this, there are actually several different methods. You might have learned a method, like some people have the snowflake method, or the star method, or the slide and divide method. I'm going to teach you the method that I prefer. It's in a box, and personally, I like this one because when we're doing the reverse of this process, I also use the box. And I think it just makes it connect better. And I think it's easier to remember to do it this way. But there is a process. There are some steps that you have to follow. So if we go back up here and we look at number 3, create a 2x2 box. Place your ax squared, which is this right here, in the top left, and your c are unfoil method. So this is just part of the setup. A times C. And that gives us -45. Hang with me. Once we get through this process 2 or 3 times, you'll get the hang of it. So we're just going to go step by step. We need 2 numbers that multiply to be -45 and add to be -12. So I'm on, if you're following this step by step, I'm on step 5. 2 numbers that multiply to be this -45 and add to be -12. +3 and -15. Very good. It says once you find these 2 numbers, put them in the empty boxes along with an X. It doesn't matter which number you put where. Just for the sake of not getting confused, I would suggest putting yours in the same 2 boxes that I did. And then we're going to look at each column and each row separately, and we're going to find the GCF of each column and each row. So let's look at this column. 9x squared and -15x. What do those 2 boxes have in common? Or what can you divide both of those numbers by?
3.
You can divide them both by 3, and they both have an x. So I'm going to put a 3x there. So you can divide 9 and 15 by 3. What about 3x and -5? You can't divide them both by anything, so you put a 1 there. Because technically you can divide them by 1. What about 9x squared and 3x? 3, and they both have an x. What can you divide both of those by? 5. Now here's a little rule. If the first box is negative, you have to put a negative. Now at this point, you need to do a glance over and check. It's really easy to do right here. It does not take long. If you multiply the two things that are on the outside, they should equal this number on the inside. Is 3x times 3x 9x squared? Yes, it is. Is 3x times 1 3x? Yes, it is. Is 3x times negative 5 negative 15x? Sure is. Is negative 5 times 1 negative 5? Yes, it is. So that's telling you you probably did this right. Another way that you could check is on your y equals. Type in your original problem, 9x squared minus 12x minus 5. And then we're going to type in what's here on the outside. Those are your factors. 3x plus 1, 3x minus 5. So I'm going to type those in. And then I'm going to hit graph, and I'm going to see if these two parabolas are the same. I'm going to see if they actually overlap each other. Completely, perfectly. And it is hard to tell on the screen, but they did. So the first, if you do it on your calculator, you'll see you have the blue line, and then it'll go in red right over top of it, which tells you those are the exact same parabola, so you have factored it correctly. So your factors are 3x plus 1 and 3x minus 5. How do you get the x-intercepts from here? Set them equal to 0. Now you're not going to have an x-intercept at negative 1. You're not going to have an x-intercept at negative 3 and positive 15. Okay, so you have to actually set it equal to 0 and solve. This would be 3x equals negative 1. So x equals negative 1/3. This one did not cross the x-axis at a perfect, nice, neat spot.
This is just a different way to do the other ones.
Well, if there is a number in front of the x squared, you have to do something like this. If you Google, like if you get on YouTube and you look up factoring where a is greater than 1 and you look at different videos, you're going to see lots of different methods. You might see the slide and divide, the snowflake, but regardless, somehow you have to get to these factors. No other factors will work.
What is the snowflake?
I don't even really know. Yes.
So, like, what's the difference between what we're doing now? Like, I understand the difference, but like, why is there two? Like, is it two different methods?
Then this.
No, like the one we just did above it and the one.
Well, because what we did above it right here looked like there was a number in front of the x squared, so we would think we had to do the box. But when I really looked more in depth, I realized I could factor out a 3, and by doing that, it made it an easy problem where there was no number in front. There's no number here that I can divide all 3 of those by. So I can't do that.
Four.
Yeah. All right, so let's look at number. Okay, I went to number 9. I misnumbered, so we're at number 9 now. If I look at 3, 8, and 4, is there anything that I can divide all three of those by? Not evenly, no. So I have to use the box. If you YouTube it and you find a method you like better, go for it, but I don't think any other method is better. There's a slide and divide. I don't know. Alright. 3x squared, 4. Stay with me. So to fill in my other two boxes, I need two numbers that multiply to be what? 12. Where did I get 12?
3 times 4.
3 times 4. Did you not say 12?
No, you
Oh.
said 4.
Oh. I can't hear. I just assumed you said 12. It is your A times C. Technically, in those easier problems, we technically are doing A times C. But A is always 1 in the easier ones. Okay. You have to do 3 times 4 to get 12. And then add, it's still your B, negative 8. So two numbers that multiply to be 12 and add to be negative 8. Negative 6 and negative 2. And you have to put an X with those. And then we're going to look at each row and each column individually. What do 3x squared and negative 2x have in common? Just 1 and x. Yeah. You can put 1x or you can just put x. Negative 6x and 4. I am going to put negative 2. I'm specifically putting the negative because the first box was a negative. When you go back and you're checking your work, if you miss this, you should notice that, hopefully. Okay. What about 3x squared and negative 6x? 3x. A lot of people here put a 2 because they're like, okay, well, 6 divided by 3 is 2. You have to ask yourself, what can I divide both of those numbers by? I can divide them both by 3. And they both have an x. What about this last one? Negative 2. And so my factors are x minus 2 and 3x minus 2. If you want to check on the calculator, 3x squared minus 8x plus 4, and then check my factors. It does not matter which factor you write first because they're multiplying. 5 times 3 is the same as 3 times 5. And it has finished, and there's one parabola, which means it overlapped. If you do it on your calculator and can see the colors, you'll notice that. So I factored it correctly. So this one, it does have one x-intercept at positive 2. That was a nice whole one. I can see that right here. Okay. The other one, I get 3x equals 2. So x equals 2/3. Are there any questions so far? Yes.
What? So how do you know to do that problem? You get x equals 2/3.
Like how do you know to do that extra step here?
Yeah.
This right here gives you the x-intercepts. So it depends on what the question is asking you. On all of these, I'm asking you for the x-intercepts. So these, what I have in boxes, are your x-intercepts. What's in parentheses, that's considered your factors. You might see a question, especially on the ACT, it just says factor. If it just says to factor this, you stop at the parentheses.
Yeah.
If it asks for the x-intercepts, you take it that step further. Okay. Number 10, is there a GCF? No, there's not.
Dude,
I love these boxes, they're so fun.
I'm so glad you think so.
no,
No, Carter just loves them, that's why I said it.
they're just my favorite.
11x squared and 4.
This feels like it takes like 10 minutes
It does take some time. Sometimes people literally just do like guess and check. They just come up with what they think the factors might be and then check to see. But I think that is a method that could take a long time, and I like a set, clear, like if you do these steps, you're going to get the answer. I don't like guessing and checking. Alright, so I need two numbers that multiply to be what? 44. How did you get 44? Yep, 11 times 4. And those same two numbers need to add to be 45. What are those two numbers? Yep. 44 and 1. We're going to start figuring out what our factors are. So what can you divide 11x squared and 1x by? 1 and x. What can you divide 44x and 4 by? 4. You can divide them both by 4. You don't divide them by each other. You say what number goes into both 44 and 4. What about 11 and 44? 11, and they both have an x. 1x and 4 is just 1. So double check either by looking at the calculator or by saying, okay, 11x times x is 11x squared. 11x times 4, 44x. X times 1 is 1x. 4 times 1 is 4. So your factors are 11x plus 1 and x plus 4. To find the x-intercepts, you set those equal to 0. And it has x-intercepts at -4 and -1 over 11. I want you to work on questions 11 and 12 by yourself. Alright, look up here.
Oh, that's why I'm
Don't even act
saying.
like
Oh
you.
my
Don't
god.
even act like you.
The 2x squared has to go top left. The -15 has to go bottom right. Basically, you put your first and the last in the first and the last. Okay. We already figured out we needed two numbers to multiply to be -30 and add to be 1, which are -5 and 6. All right, and you get 6x. So then we look column by column, row by row. What can you divide 2 and 6 by? 2. You can divide them both by 2. And they both have an x. What can you divide these two numbers by? 5. But it needs to be negative because your first box is negative. What can you divide these two by? Just 1, but they also both have an x. What can you divide 6 and 15 by?
3.
You can divide them both by 3. Does it need to be negative?
No.
Nope. Does it need an x?
Yeah.
No. They both would have to have an x.
I thought it was only for first box.
That's the negative.
Frick, dude.
So, there's some of you are like messing up with the negatives, messing up with your x's. Check it in the calculator. Don't skip that part. Don't get so confident as if you've got all these right, and then maybe okay. But some of you are messing up a little bit. Take that 1 minute that it takes or less. Double at this point, type in 2x squared plus x minus 15, 2x minus 5, x plus 3. Now when you type in your original, it has to be the one that's set equal to 0. And those did overlap. So we have x-intercepts. If from this step, if you know that it's x equals 5 over 2, that's fine. And you know that it's x equals negative 3, that's fine. I can do those 2 steps in my head. And I think I'm okay with that. If I see this written out, you don't have to put equals 0. You don't have to put plus 5, divide by 2. But if you don't put that work and you get the wrong answer, I cannot give you partial credit. So you're taking that risk. All right, you got enough time to work on number 12. I will work on it and then just put the answer up. You should have x-intercepts at negative 8/5 and at positive 1. Are there any questions?
Oh, everyone's 5 minutes.
Have you not